This is the Continental AVDS 1790. This is the monstrous power pack that comes out of the tank. With forced air cooling, that is indicative of the aircraft designed by nature. You see a lot of the aluminum heads and aluminum jugs with fins in them, as opposed to a liquid cooled engine. So this is what's referred to as the pack. It's basically a post-World War II step in tank technology. And what that means is prior to the pack, components of a tank, drivetrain and engine had to be pulled out individually. This took time, equipment, and lots of different jigs and methods to accomplish the task. Right after World War II, the notion of the pack was developed, and what that basically means is everything required to run the tank is all built in a one-piece frame, if you will, referred to as the pack, and everything such as your radiator, your transmission, your engine, all comes out rapidly from the tank. And then they moved into the notion of quick disconnects. So nowadays with modern technology, thanks to the concept of the pack, tank crews can unhook rapidly and pull a tank engine, depending on the tank, in a very short amount of time compared to the old stages of individual components coming out of the vehicle. So AVDS 1790, what does that mean? It's an acronym, and basically the A is for air cooled, V means it's the V cylinder arrangement of the engine, it's a diesel supercharged, and then your 1790 is the displacement in cubic inches. So it's a Continental engine, and then the transmission was done by General Motors, and then the tank itself, obviously Chrysler, as we talked about. So this engine, at the birth of its time, was actually more at its very core an aircraft engine, but it was ultimately decided that it was too heavy and too big to be in an aircraft, and then the technology basically transferred over into tanks and various armored vehicles. The engine was originally gasoline. The engine had bad fuel economy, so they ultimately upgraded it to a diesel, which is what you see today, and it is a very effective, efficient, powerful engine. Going through some of the characteristics, again, it's a 4-stroke V12 with 1790 displacement. Cooling is basically air cooled with forced air cooling, so that is indicative of the aircraft designed by nature. You see a lot of the aluminum heads and aluminum jugs with fins in them, as opposed to a liquid cooled engine. There were many configurations of this engine depending on the vehicle they were installed in. This particular version is what's referred to as the AVDS 1790 2 Charlie, and the 2 Charlie was basically featured in all of your variants of M60 main battle tank. And then you have other variants with different configurations and slightly different modifications that would go in, like your M88 and your M728. Additionally, the Israelis also took this engine into their Merkava tanks and did massive modifications to them to pull much more horsepower out of this engine. This engine, as it sits now, runs at about 750 horsepower or 2400 RPM. The M60, it's brought to you by Battlefield Vegas, so bloody get online, champions, right there. Hit Battlefield Vegas. The tank's available for rent, so you can actually come out here into Nevada and get a ride on the tank, do a shooting package, and fire the main gun out of this beast. The engine is actually configured to do a filter change in the tank. You do not have to pull the engine out of the tank to conduct a minor service. So a lot of your filter systems are conveniently located to where the crew can access them from inside the tank. So we'll begin with flow of fuel. As you'll see later on, the fuel tanks for this engine are actually belly tanks that are shaped to contour the engine itself. And the first point of entry for the fuel comes in from a fuel line, and this is your first section of fuel filter, and that is basically your water separator, and that the fuel moves through that, and then it moves into our primary fuel filter. Inside here are two massive cylinders and an additional one in the middle. Both of your fuel filters have bleed screws, so if the system is run dry, those of you that are more mechanically advanced would be knowing that air inside a diesel system is difficult to deal with. So these screws at the top here, what happens is when you apply power to the tank before the tank is actually running, there is an electrical lifting pump that moves fuel out of the fuel tank and into these filters. You would be cracking these bleed screws, and as the bowl fills up, it'll force the air out of the system before it enters into the injection pump. The two engine oil filters are behind this panel here. Once again, conveniently placed. You just pull this face off and you have two major filters that come out of there. Once the tank is actually running, the role of the lifting pump is kind of negated whilst it's still working. We then move to a mechanical fuel pump, and that's what this is here, and this is driven off the engine. So obviously the faster the engine's running, the mechanical fuel pump is demanding at the same revolutions of the engine, and basically fuel is done through the mechanical pump once we're started up. Then you also have your linkages for the engine. It's really simple. You really only have your accelerator and then your engine shutoff. So engine shutoff is an electrical solenoid, but it can be manually shut off as well. And then we have an hours meter at the top here, which is also conveniently placed so crews can actually check the hours of the engine. Tank operations are usually run by hours, not like an odometer, which you would see in a vehicle, like a normal motor car. The reason for this is during armored warfare, a large proportion of the time the tank is running, the tank is just sitting at idle, waiting for orders, waiting for its next movement, or just conducting observations or clearance. So given is that the engine's running for long periods of time at idle, it's really hard to gauge where we're at with wear if you're doing this by mileage. So that is the reason they introduced an hours meter. The same thing is also done on a lot of heavy equipment like dozers and excavators. Given that the engine is air cooled, a lot of people might view these as radiators, and they're kind of the same thing, except we're not using liquid coolant that moves through the engine to cool the engine. Rather, we're cooling engine oil and transmission oil, which is what these big units are here. So when the engine's running, it's pulling oil pressure via a pump through this cooler here. Air is actually pulled through these and out the top of the engine, which we'll talk about in a moment. The engine wiring harness is actually very easily placed for the quick disconnect on the top of the engine. So when the crew goes to unhook or hook up, all of your major wiring is done through 4 plugs at the top of the pack, which is what you see running down the side here. This little section here, which you see, it's not on every variant of these engines, but what this does is it basically allows you to pull samples. So if they need to sample where the engine's oil is at, they would disconnect one of these, put it into a bottle while it's running, and they would just open one of these taps and it'll feed oil into a little bottle to collect samples. The engine is actually dual turbocharged, so this is one of your turbos that you can see here. So you have your air intake moving through, it fuels the engine, and then your exhaust side, and then your outflow exhaust through the back of the tank. These little units here are not featured on all of the AVDS engines. It's more of a modernization. But what this does, it's essentially a sensor that if this turbo begins to suck massive amounts of dust and you have an air filtration failure, this sensor will actually trigger the master warning light in the engine, and that'll allow the driver to know that he has to conduct a shut-off. You can actually see the air intake manifold, which runs from the underside of the engine through the jugs, and then the exhaust goes out the top side. But that's essentially what this unit does along here. In addition to the air intake, you also have the preheat engine assistance. So you have an ignition coil up this end here, And once that's excited, there's a spark plug that runs into the air intake and a small amount of diesel fuel, and that actually jets flame in through the air intake to preheat the engine. It is a very effective system. On each side of the engine there's an accessory drive, and it's basically configured the same on left and right. So behind this flange here, when the engine's running, your two accessory drives are gear driven either side. That drives your generator and your starter motor. This particular generator here is one of many types, and to conduct our services and our engine change for the M60, we had to reconfigure this generator from a single wire air-cooled generator, and we had to swap it over to a more modernized 3-wire oil-cooled generator. What does all that mean? We basically had to change the engine wiring harness and then our oil flow coolant lines into the side of the block, which are not present on our older 1-wire generator system. And then here's a good opportunity to view the engine mounts. So when we look in the tank about how this mounts, these actually glide into the bottom, and once the engine is seated, it automatically locks. There is no need to undo or connect an engine mounting point from the bottom of the engine. A very handy system, and also very convenient for, once again, that quick engine change. And now at the top of the engine, we have our main fans. These are a full-time drive fan, which basically means as soon as the engine's running, the fans are mechanically driven. They do not turn on or off with a clutch or an electric fan. Given that they are engine driven, the harder the engine is working, the more air is getting forced through the engine. The flow of air actually goes up. So when these are running, they're pulling air in through the sides, which goes through our coolers that we talked about, cools the center of the engine, and then shoots the hot air out. The only other components on the top of the engine would be our oil level dipsticks. One thing to note about these engines is when you do conduct your oil check, you can judge the level of oil with the engine off, but typically it's done with the engine running. The reason for that is when the engine's static, all the oil that is normally getting cooled in your coolers falls down to the pan of the engine, and the engine might appear overfilled. And once we get this thing running and all the oil heats up and thins out, and as you know, when oil heats up, it thins out, therefore your level increases as well. But with the pump running, the oil's also moving out of the pan and filling the coolers. And once that happens, that's the best way to gain true engine oil level, which is what we're going to check when we conduct our ground hop test. There's a lot here that is also not exposed, and the reason for that is your cooling ram airflow. When you do have a air-cooled system, you need to shroud everything. In other words, if we didn't have all these covers on the top of the pack, the fans would not be as effective as they need to be. Getting a look at the transmission pack. This is the output final drives for the sprocket power, which drives the tank. And then these rollers here are also part of your quick change system. So you'll see inside the engine bay, they actually hook into a guide. Once they're in the guide, the engine automatically rolls into the position that it needs to be at, rather than having to adjust your crane left, right, and forward and up and down. The transmission also features accessory drives for a hydraulic pump. For other variants of the tank, such as the 728, that runs a hydraulic crane and a hydraulic winch, you can unhook this plate here, and there's an accessory hydraulic pump that is driven off a drive inside here, usually mounts along there, and then that would feed hydraulic oil out to your accessories. And then all your various linkages on top of the tank here, such as steering and gear select, once again are all accessible by the crew with the engine inside the tank for things like linkage adjustment. The transmission is also air cooled, so you do have your output pump transmission oil flow valves, which run out to the coolers and then back again to cool the transmission fluid. So the purpose of today's ground hop is we've done a major service on this engine. We've reconfigured the generator from a single wire to a 3-wire like we talked about. We have to run this engine on the ground before we install it in the tank, and we're going to conduct various checks of the engine's functionality. And that's done for several reasons. Then the first one is you don't want to drop the engine in the tank and then discover that you have a problem. Additionally, you can't see most of the engine while it's running inside the tank, so you may miss things like leaks and such. So we're going to conduct our ground hop run today, and we're going to check such things like, is the air flowing in the direction that it needs to be through all the ports? We're going to look that both our turbos are running and actually pulling air, and we're going to conduct checks on all our different linkages and shutoffs and make sure they're all functioning correctly. So a really good opportunity to show you inside the engine bay of an M60, M48 or M728, basically all configured the same. As you can see, there's a lot of room in here. These are the two belly fuel tanks that we talked about. They can be isolated for left and right, but typically there's a crossover right in the middle here, and normally you would draw off both tanks. The reason you would isolate them is, say you take a hit and one tank is losing fuel, there is a tap in here to switch off, and that tank will drain out and you won't lose fuel out of the other side. These are the service access panels that we talked about. So the front of the engine would be facing right here, and that's where they do their filter change and they can adjust their linkage. These are the guide rails, so those mounts down underneath the engine. Once you hit the roller bearings on your guides, the forward mounts are going to naturally glide in here and actually lock into place in these mounts. There is no need to connect or disconnect this section, which is incredibly handy, I think. These are the guides for the rollers. So once the engine's actually in place, as soon as you hit that, everything else is going to fall naturally where it needs to be. And there's only rear engine mounts that you need to hook up, which is located right here. And then you can see here the drive teeth for the sprocket itself. So your engine output drives on the transmission link up to these sections here. The connector for this is actually made of brass. So the brass part of the connector is your sacrificial piece. So if you have an issue with locked up track, or there's an issue on the engine, that brass connector is going to give and crack before it actually flows power out and damages a lot of your other major components. So your air intakes are on the outside of the tank, but during your NBC procedure you can actually switch for air intake to be done and filtered through the inside of the tank, and then the main engine air intake after the filter comes out here into the engine. So again, the beauty of the setup in this tank is that it's all mechanical, nothing's electrical. The advantage of that is if you have a completely dead electrical system, in other words, your batteries are totally drained, even though you're able to jump start the vehicle and the generator is putting out power, if those batteries are drained in some other vehicles, your electronic gear selectors will not function. The advantages of all mechanical is if the vehicle's completely dead, it's slaved, you disconnect the slave lead, the tank will run fine because everything is mechanical. So you can see an example here on this side is, this is the park brake linkage. So the driver can apply the park brake. This would hook to the top of the transmission. So prior to assembling the engine as it is, we did what's called the compression test, and that's where all of your fuel injectors are pulled out of each bank, and then we run an air compression gauge and we turn the engine over by with just the starter motor, and we check that there's enough compression in each cylinder individually to support combustion. That'll tell us whether we have a dead cylinder or our rings are starting to go bad. The lower the compression is, the more the rings are beginning to wear. So we conducted our pressure test. We have good compression on each cylinder. Once the engine's actually running, we're going to use a temperature gun, and we're going to shoot each cylinder and get temperature from each cylinder when it's up to temp. What that's going to do is that's going to tell us that each cylinder is actually firing correctly. So for example, if you get ambient heat of the same consistency in each cylinder, and then you have one cylinder that is drastically a lot cooler than the rest, it means that the fuel in that cylinder is not firing, and you're just essentially fuel's going in there and it's not firing, and you'll see a cool cylinder and you'll see that unburnt fuel actually shoot out of the exhaust. Another check we're going to do is with a rag, where you hold the rag over the exhaust and you're looking for constant blowout. What would happen if you have a bad valve or a valve out of time? The rag will quickly suck back into the exhaust pipe. That means that when the engine is in its firing compression state. If that exhaust valve is not functioning and open, periodically as the piston drops, it'll suck the rag back into the exhaust. So that's another check that we're going to conduct. Additionally, we're going to check that our linkage is actually working correctly. So these final drives are going to spin naturally even when the tank is in neutral, and that's because with this not being mounted, there's no preload. So even under neutral power, these are still going to spin. However, there should be no resistance required. While these are spinning, we're going to be able to grab these by hand and bring them to a stop. And then we're going to put the tank in gear and actually get these spinning up and run the steering. And you'll see one side move faster or slower than the other.
All right, so to get this running on the ground, basically what we're gonna do is hook up our own little electronic fuel pump, since we're outside the tank and not using the one that's located in the fuel tank. We just run it straight out of a jerry can. And basically what that's going to do is it's going to fill up from the fuel filters and allow the system to be full of fuel, so that when the mechanical pump kicks on, it has something to suck through and give our engine life. So we only need battery power to start the engine. It doesn't need to be connected for it to be running, but our starter is located right here. And basically we found the positive side that will hook up directly, and the negative side which grounds out to the tank itself. And then you also have a small relay wire right here, which is actually what gives the signal for the starter to actually engage and then turn her over, which you'll see here in a minute.
Give me fuel. All right.
Down just a little bit, Rich.
Clip prop.